So hello guys, welcome to my YouTube channel. This is yet another video. If you have not liked or subscribed to the channel, please do so. So today I'll be demonstrating how I made this gadget and how it works. So one of the problems faced by tokens, so I know everyone has used a token, so it's where you recharge or you pay a certain amount and then the Kenya Power sends you some units and then you dial on the keypad which comes with the token unit. So there is an issue brought by these tokens, which is, so once the token is below a certain voltage, maybe say 1 unit, it takes some time before it goes up. So one added feature to this system notifies the user that the token is below a certain level, and it notifies the user when there is a low unit, maybe say when the units go below 5 units. So another added feature on this system is that you can reload your token using your phone directly. You don't need to go directly to the token and dial the token. The token which will be sent by the Kenya Power. So the ordinary token does what it does, that you have to send or you have to pay first for the token, which will be sent to the Kenya Power, and the Kenya Power will send you the token number, and which will then on the token. This system simplifies this system by you just sending the amount of money you want to pay the token, and then the confirmation message will be sent automatically to this system, which is in our case the token. See, the system which calculates the power you consume. So it will directly send the message here, and it will authenticate, and it will recharge automatically the token through a system which will be shown you later. So the system has those features. The second feature is that it can switch off the load, which in my case I've used a bulb. Whenever the voltage goes below or there is not enough token to supply the load with power, so I'll be using a current sensor which counts the power consumption in this bulb. It will detect. Let me open the gadget, which wasn't easy to build. So the gadget uses a 12 or 2020 by 4 LCD display with a adapter, which simplifies the pins which I'll be using. So I have a GSM. This is a CM800. I think I've never used this, but this is the other version of CM800. It's just a GSM network I used. The main brain of the project is an Arduino Uno. It has a CMD IC, which on the other project I've used a deep tape IC. So the part that senses the power consumption or the current consumption on my load is this sensor, which is a 5 ampere current sensor. This is a power supply. This is a relay for controlling the load. This is used for switching on and off the load. I got a back converter. This is just for minimizing the voltage going into the CM800. If you go through its specification, you have to supply it with a 4.5 volts, which in my case I'm able to control that voltage using this back converter. So for electronics part, that's all. I think that's all. This is a cable which I'll be powering the gadget with. I'll just plug into the socket. This is the load which I'll be controlling. So first of all, I will power the gadget. So once I power the gadget, what I should expect, not my token haven't reload anything, the system will send me a text notifying me that first it will send me a welcome message, and the other text it will show me tell me that there is no enough units on the system and the system is off. So let me power the gadget. So that's what I'll be expecting on my phone. So this is a welcome message, welcome energy meter. It will take a while before the GSM connects to network. Let's just be patient. So for now, as you can see, it's displaying that there is no unit and there is no money on the token, and as you can see, it has sent me a text: your balance is finished, please recharge. So for this pulse, I've used it to count the number of current, or to count the current which the bulb will draw for now. So let me reload the system. I'll type RU code, R and U is capital, RU code 1. So I'll send that to reload the system with some token, and I'm expecting a feedback message and to reload the system, and it will activate the bulb. So I have 6 units at price 90 bob, and from here you will see that the pulse has started to count because the load is on. So it's 0. So one of the hardest thing about this project, as you can see from the other side, that your charge is updated and your balance. So I've reloaded 100, which is 5 units. So the feature that I was talking about is that when it reaches anything below 5 units, it will send me a text: your balance is low, and that's the text. So I can reload 200, which I'll dial RU. Record 2, which you reload it with 200. So as you can see from here, it is deducting. It was 5 units, now it's 4 units, and the pulse is incrementing. So it has added the units. Now it's 17 units at cash 255, and it has sent me a text: your recharge is updated. So the other feature I want to show you. So first, let me unload the token, which I've programmed it to deduct the amount on the system. So our code 5 is for deducting the system, deducting the units, and then I'll upload 100 cash, and then we'll see if it's consuming. So whenever it's consumed, it will be deduct a certain unit on the system. So this code will deduct all the units on the system, and will switch off the bulb. So let me recharge it with a small amount. So my case is 6 units, so I'll just wait until it goes below 5. So below 5 it will send me a text, and if it goes below 0 it will switch off the bulb. So let me just wait a little bit. So this is the software I used on the system. I'll not go into details about on the I'll not go into details. It's a long software. I've programmed it in C++, so I'll be taking you through the crucial parts of the program. So this is a variable which I connected with the GSM on pin 9 and 10. I've used a relay on pin 12. This is a string which holds the number. One is the consumer number and the other one is the company, which in our case is a KPLC. So the crucial part on this software, which I had difficulty in programming it's this part which I've used interrupts. This is a timer. It's a 10 milliseconds, and it will be calling this function which takes data from the sensor. This is the current sensor. So this is the message which was displayed at the first power the gadget, and this is the text which I was receiving. Is a link to my YouTube channel. So all these if statements, it's a condition. I've used if condition. It will check if the code I will be sending as this type of format, which is LUCODE 1 or LUCODE 2. So if it doesn't have that format, it will neglect the text. That's for security purposes. This is the ending part of the LUCODE. Which if you want to reload 100, you have to end the code with a 1. If you want to reload a 200, you end the code with a 2. So this is the place which I've used if condition. If total amount is equals to a 5, it will send me that your balance is low, and if the total limit is a 0, it will send me a text, your balance is finished. So these are function. Send function is for data, for inquiring data. This is for reading EPROM and for writing EPROM. So one of the added feature on this system is that even if the power goes off and it comes back again, it will still remember the token number which it was loaded with. As I've utilized the EPROM to do such a task. This as a read and a write. I will be writing, I will be reading the EPROM certain addresses. This is the addresses, and this is what I'll be writing on the EPROM. This is for printing, is a function for printing the LCD. This is a function for reading the sensor data, which I've used interrupt. One advantage of using an interrupt is that even if the program is running, it can interrupt the main code and do this task. I've given this task a priority, and this where it will always add or increment the pulse whenever it senses the count is anything either above 1 or is equal to 1. I think that's all with the code. If you like the project, please remember to like, share, subscribe, and I'll see you on the next video. Thank you.